hello everybody. I hope you can hear me. If you're not, put your headsets on and then you can hear me properly. Welcome to this session. Welcome to Let Generative AI Agents or Let Generative AI Agents do the work for you. I hope you're excited as I am because this is like a really cool topic. It's a hot topic right now, not for Cisco, but also for the whole industry. And I'm pretty sure that like lots of things can be done with AI agents, and I would like to give you a perspective on that. So agenda would be like this. I would like briefly to recap, for me, the most important aspects of generative AI, because I don't think a lot of people know the exact difference between predictive and generative AI. So just for you to know on a concept level. But then I would like to go quickly already into like the AI agents one-on-one topic. So what are AI agents? What can you think about this? What is the difference to assistants? And of course, architecture-wise. So like, what are the building blocks of the specific AI agentic solutions, and for you specifically, what are multi-agents and what are frameworks? So what kind of frameworks can you use right now? So I will go deep already with use cases which can be already implemented. I also have some code which you can share as well. And with that, yeah, I'm really curious what you think about the session. For those who don't know me, I am part of Cisco DEVNET, developer relations. I focus completely on data and AI, and I'm based in Vienna in Austria in Europe. My latest project, so you can also follow me on GitHub, of course, is API and code assistance for Catalyst Center. And soon, when I will release my AI agent content, I will put it there as well. But it's not out yet, but it's like 90% done of what you can see here. All right, so I guess like all of you guys, or most of you, you read the news, right? So I usually like to see as well on Google News. This was in November 24, by the way, right? Like I just screenshotted this one from the presentation back then. And you can see that, here we go, like even in 2024, OpenAI says AI agents is a new thing. Like The Verge says, yeah, this is the future. Then, of course, here we go, even Forbes says, this is like, you can achieve ROI, like a good ROI with AI, with the agentic world. So like, what did it change? So I checked again on Google News, just typed in AI agents, and here we go. Like in January 25, it's like again, Forbes, yeah, this is like the new thing there. Satya Nadella even says, and I will come to that in a bit, software as a service is out. AI agents are in. This is like the new world. As well as also Chuck Robinson is saying is like full agentic, and also Cisco, we have also like have a research paper on it from Cisco Outshift about an agentic internet. I will come to that in a bit. And then, yeah, of course, OpenAI launches like various things about AI agents and generators and so on, as we do. So if you Google this as well, Google Trends, also I like to see metrics, you know, and metrics don't lie. So with that, you see the interest over time. Like this is like on Google Trends. You see like nobody was talking about AI agents, like just a minority. 2021, it goes up. It goes up like this, 2024, like the interest is there, the spark is there. And yeah, like it can be done some stuff, like compared to like a normal LLM, you can do shit. Like you can do, sorry about this, you can do like stuff there. All right, so are AI agent a new big thing? Like you have here a GitHub repository where you have a whole collection there about various agents, open source, closed source. Some are more like, this is, you know, things are getting added, startups are coming out. So a lot of companies are getting more into specific AI agentic world, more are coding related, more about like, you know, low code solutions, more like HR related and so on. So there is a huge like a pillar of what you see, like there are many things what AI agents can do right now. So it's kind of like a chaos, it's kind of tricky. For me as well, you can choose now a couple of hundreds or 20, so a couple of 20s frameworks there, where it's kind of difficult to choose from, right? And I will go into this when it comes to the framework in a bit. So my goal of this session for you is to understand AI agents, the whole concept there, and also since we're in a DEVNET zone, like from a developer perspective. So like also I will go in some code, not so much, so for those who don't know Python, but I will also show you real life use cases, how to get data from a switch and how to solve troubleshooting and errors. And then, of course, concept, frameworks, use cases. This is like, I really would like for you to get something out of it, of this session here. All right, AI recap. So I hope maybe I will bore somebody with that, but just high level, I think this is very important. Two key understandings, two major concepts there. First of all, key understanding one, when it comes to deep learning, when it comes to training LLMs even, there are two important stages which you need to differentiate. At first, it's the training phase. Training, you teach a model to do specific tasks using existing data what you have. So you teach basically a model. You don't do any interferencing, you just say we train the model. You don't do anything else there, you just create it based on specific data. For that, you need powerful GPUs, especially with LLMs. We see it like with the NVIDIA stock or NVIDIA numbers, it goes up. So with that, you need a lot of GPUs. On the other side, there is another stage, and this is like where, for AI agents, it's, I would say, like more important, because that's in inferencing stage. Because here, you use this trained model, what you had here, the training, what you trained, you use it to make decisions. And this is where you don't need that many GPUs. Of course, it depends on the use case, right? So like images, you need more GPUs if you would like to basically create images or like videos even. So keep this in mind, AI agents are usually only do the inferencing part of the specific trained model. Second key understanding. There are two, I would say, major. Of course, it's kind of like there's a discussion point, but I would like for you to understand there are two subcategories. One is predictive AI. So you have seen it maybe in Gate popularity in 2010s. It was all about analyzing existing data for prediction. It's about what is the outcome there, anomaly detection. So like you see that there are specific use cases where you don't need an LLM. An LLM is wrong for specific use cases. Just an example here. I hope I don't bore you with that. It's like very like, is it a cat or a dog? So maybe if you know about this. You have an image data set, which is with labeling, with images of a dog and cat. You train it on a CNN, convolution neural network, not an LLM. You have the trained model, and with that trained model, you basically have an input image, is it a cat or a dog, and then you have a prediction output. Like to 95%, this one, for example, is a dog. All right, like this is fun, but of course, if you'd like to do something network related, then you can do this. And you can do this also with Splunk, with the machine learning toolkit already, where you predict basically based on historical data, the usage in the network. So what is the predicted usage there, upcoming like in April? So here is the prediction. Here you see the prediction that, all right, this is basically the data which, like how the peaks are in my network. So coming back to the subcategories basically. Predictive AI, again, historical data, doing some stuff. But now, 2022, November, ChatGPT came out, and boom, generative AI was like brought to the mainstream. So you can now create text, images, audio, and other data. So with that, generative AI is kind of like a evolution or like a new thing within AI, in the umbrella term. And here, this is where generative AI or agentic AI or LLM-powered agents, however you would like to call it, is coming more into play. Because here with generative AI, you can talk to people, you can talk to the assistant, you can talk to the agent can do some reasoning. This can't be done like how it was done with predictive AI, but with generative AI, it's like a new set of tools, like a new opportunities there. So how does it do? Just 2 slides on this one. Large language model, they process the text using specific tokens. So they analyze the tokens, and based on the next probability of the next token, the token will be set by the LLM. I have an example here, and this is the last slide about the LLMs, and then I will go to the agents. It's about, in LLM training, you say, like if you would like to train an LLM from scratch, you take like trillions of tokens of text data, train it with the transformer architecture, you have the LLM model, and then you have here the, again, training and inferencing, you have here the trained model there, and here what did you do with ChatGPT and so on? You asked it. You asked when was it with Cisco founded, for example, and like for you to understand like how it works, it's basically gives the output in a way of the next token probability, the probability of the next token, like Cisco Cisco system, because systems comes after it with the higher probability than was, for example. And then so the LLM is basically getting the data out until it stops and says, all right, this is done. And this is how also like AI agents work like with that. So like keep this in mind that with generative AI, this is how it works, the LLM process. And the predictive AI, this is about like numbering. This is about analyzing historical data and then predicting basically the future or finding specific patterns there. Good, I hope we are all now on the same level. Like with that, all right, to understand very like high detailed. And now let's move to the AI agent world. All right, so like I like sometimes definitions. I mean, it's kind of like tricky in order to understand, but once you know it, then it's kind of like to understand. But let's go through it like step by step. So like this is the Cisco definition of AI agents by Cisco Outshift. It's basically autonomous software entities. So think about it like a software or software product there or software like part of it. And this piece of software is capable of generating content, making decisions, even doing some actions there, interacting with the environment, in order to have an output there, in order to complete specific tasks. Now, an example, a really like easy example there. So like we should ask like an AI agent intro example is about, hey, let's create, like we're in Amsterdam right now, so let's create a 2-week itinerary for the Netherlands. Let's see. So what would you do? Like if you would ask like a classic LLM, so you would maybe go, ChatGPT is like a wrong example because ChatGPT is also working kind of like an agent. So like just a small, let's take Llama for example, pure LLM. You have the input example, you say create a 2-week itinerary to the LLM and you get an output there. The output is static. So the LLM doesn't interact with anything. The LLM is basically completely like a stable, static. So what we do here, and why AI agents are so like really cool and really interesting about in the whole industry right now is, you can extend this LLM with more functions and with more action items and execution tasks even. So for example, here you have the 2-week itinerary from the Netherlands. The LLM is basically saying, all right, like I will create now, like it gives itself like an agenda or a plan. I will create now like an agenda for the 2 weeks. I will furthermore do some web research, like search the web about it and bring back the results. Then I will go into self-reflection to actually see, hey, do I like what I just wrote actually? And then I can even extend it and saying, hey, like actually like on this weekend there are super cheap flights train tickets even in order to go to Eindhoven, in order to go to the north or to the south more. It does it like in an iterative process there. In exchange also with the LLM, and then the user has the final output and also the better output there. So, and I will go more and more deeper in the networking context now as well. Now, maybe you might ask, okay, like what is the difference between AI agent assistants? So the difference is not that big, I would say. So usually they say autonomous decision making is more an agentic topic, like solving complex tasks. It has no or minimal interface, so you basically write your workflow, you run your agent as a service basically. And then, for example, it's like a network troubleshooting agent. And I will show you one towards the end in a demo. AI assistant, this is about routine tasks like Cisco AI assistant or travel assistant. Hey, I would like give me the data on or the best flights on this date, or I would like to cancel my booking and so on. This is about it. Now, let's go more deeper into the AI agentic world. And this is about the building blocks. So the building blocks is like, I would say like these four tools here, or these 4 big things here. So these 4 pillars is like the user is interacting with the AI agent. And there is this blue one is the orchestration loop, which means that it's like, as I said, it's iterative. So basically, in the orchestration loop, it's all about planning, reasoning as well, self-reflection, and also setting actions. But like an LLM itself can't do any actions. An LLM itself can't execute the code. So what does it do? It can use tools. Tools as in you define deterministic functions, like a Python function, for example, what this specific LLM can call and get the results back into the LLM. And I will come to function calling in a bit as well. Memory, this is like about short-term memory and long-term memory, like to have some data, some history there. In AI models, of course, you need some reasoning. So like the whole orchestration loop there, the reasoning, the planning, this is like done also with the AI model, of course. Like this is very important there. I will go deeper now into these specific components now. So maybe you've heard about this already, React framework. It was really popular since 2022 with this research paper there. And this is where many AI frameworks, AI agents framework are using it. This is like the React framework, which is called the Re is reasoning and Act is action. So it does it like this iterative loop where you basically have here beginning a task, you put it into the LLM is doing its reasoning, it's even calling some tools there, like for example here in environment you have like a REST API call, we can call the switch, it's a deterministic function where you can get data, what you would like to do into the LLM, or into the agent basically. And this is all with the React framework, which again the accuracy is really good with that. Coming now with this knowledge there to the orchestration loop. So iterative introspective process is like the brain of the agent basically. So you can use advanced prompting techniques, like I just mentioned the React framework. I won't go into details there, but here just for you to see. And these are just some tasks there. Planning, what step do I need to take? Some reasoning, self-reflection, very important, because sometimes the LM gives the output and then it's basically does a self-reflection, says, actually that's wrong, right? I need to correct it. And then action, executing the task via the tools. This is also part of this controller, basically. So the LLM, I would say there's nothing big to talk about this. There are like different LLMs, of course, general purpose, multimodal as well, fine-tuned. But basically, it's also about choosing the right model, like what kind of training data you would like to have. But usually, I would say start with just a generic LLM in order to start your specific use cases there. Now, coming back now more towards the tools, because I think this is very important and really cool. Like it makes sense, in order to do that. So function calling is the same as tool calling. You might have heard it before. Since Llama 3.1 is supporting it, GPT is supporting it, Mistral, like the whole LLMs are supporting it. And all LLM, like the AI agentic frameworks, which are coming out, they're also supporting it. Because you need, of course, like this is a specific API or a specific input, what the LLM requires in order that the function will be called, or specific input parameters need to be given. So here, just a high-level example, and I will have a demo with an AI agentic framework later on the tool calling aspect. So this is just like high-level concept of tool calling. I ask, what is the uptime of the device on DEVNET, Sandbox, iOS XE, Cisco.com? So, since the user asked this, the LLM, which supports function calling, knows about this and says, I have this Python function, deterministic in my code, get device uptime. So it links basically the query to this function, the function will be executed, and then the function will return the text to the LLM. The LLM formats it, does its magic and so on, and then it says, hey, this is the uptime in hours, in minutes, and so on. So this is where it makes a lot of sense to use the LLM in order to have some good reasoning. Like with function calling, I think this is a very good combination, let's say. And to extend your horizon there in a way, these are some tools what you can use. So you can do research tools, Wikipedia, web search. I have a demo for that with the web search one. Analysis, services, data connectivity, you can get data in, like from a vector DB, like similar to a RAG, retrieval augmented generation. So there are pretty much cool things there. Like even the RAG architecture is kind of like moving more towards the React framework initiatives, I would say, like moving more to the React frameworks there. And even so, there is for example, this function calling leaderboard as well. So you see here that this is from the Berkeley University. They actually test specific LLMs in order to how accurate they are in calling functions. Because this also needs to be some reasoning there, right? Like the LLM needs to know, okay, I need to map this prompt, this query, to my function. And this is also needs to be, you can see it here, there are the usual suspects there, but also some really nice LLMs, which are fine-tuned even for function calling, are in this list. So like if you're like more into this one, definitely check this leaderboard out. But anyways, for a first start, if you're like more of a beginner, like O4, Llama, and so on is totally worth it. However, I have to say, like Llama with 8 billion parameters, that's like it's like tricky. You don't get the best results. But I will come to that later on. Memory. I don't want to lose much time here. You just have a memory within the agent. Short-term memory, you can save specific responses there, which is important that the LLM is basically like covering the whole history there, or specific examples or learning from mistakes basically you can put in there. All right, so now in total, this is like the whole building blocks which we went through. Orchestration loop here, AI models, any kind you like, specific tools, external connectivity, and memory, short-term, long-term. Now let's put this more into action. And like I would like to have a concept there, like to have some example. So the concept example is, and now it makes maybe more sense than even, for example, why can't the host on this IP address connect to the switch on this IP address on this port? So like now let's assume, of course, the LLM has, of course, also the credentials there, or will get the credentials. So we have here Llama 3.1, we have a code execution tool basically, and a memory. So what would be the first step? The first step is about the LLM or the reasoning engine about saying, taking the steps, what are the steps to solve this issue? This is a thought. And then it says, okay, this is the action, generating a step-by-step troubleshooting guide for itself, like for the agent itself. The thought, all right. Let's start with number one. Number one is about checking the port configuration on this one. All right, so like what does it do now? Action. We use the port config check, so it maps the config to the specific task, and with these specific input parameters, and saying like on this IP address, on this interface, let's do the specific port there. Observation. The output looks okay, let's continue with step 2. So again, it gets something back, the observation, and it continues with the step 2. Action, okay, let's check the VLAN. So in the end, on the same interface, let's check the VLAN there. Observation, all right, it seems that somehow the assigned VLAN is incorrect. So there, all right, create a troubleshooting guide to solve these issues. We can continue there in order to do a full loop or a closed loop automation, of course, but we are not there yet, of course. Like this is like an example, like a network agent example, but I have one, stay tuned. I will come definitely to the demo about this where something like that works. In the end, output, summary, and steps to take, and this is the support engineer or network admin should be happy about the output, because in the end, the LLM or the AI agent solved basically the whole troubleshooting response. All right, so let's move forward, and now let's go more towards, so you know what an AI agent is, like the concepts, you know like LLMs, how you interact with them, you know about function calling there, and now let's move one step forward, and let's see, all right, about multi-agent and frameworks, how they belong together or how they are used. So there are some, and this is again, like now we are still in the beginning. Frameworks are also still in the beginning. Like if you look at all the Python frameworks out there, there is still like, there still need to be, a lot of work needs to be done. But what they aim to do, the vision is as well is basically like to have maybe a collaborative architecture where you have like agent 1, 2, and agent 2, okay, sorry, 3, should be 3, work together. And basically they communicate with each other, like just with text or with specific outputs. And I will come with the outputs in a bit. Messages, queues will be stored, and the memory, of course, like what kind of task they will solve. Another thing what you can do and what's easier as well for a start is the workflow type. So agentic workflow type. So this is about, you have a task and you know what kind of agent has its tools or capabilities. So you start with agent 1, then it goes to agent 2. It can loop here with agent 4, but finally it should get back to agent 3 and then back to agent 1. So this is like the whole loop or workflow style, which is also possible there. But now, let's think about it. Like how do this agent, like how do they communicate, or how can they communicate? And there is one thing which I would like to show you as well, which is, I think, a really cool tool as well, is about structured output. So, for example, here, and I will show you the demo, the code in a bit. Just as an example, of course, you can do different things here. We have a show version command here on a Cisco I/O6E switch. And from this output, or from this text basically, we would like to have not only like a text or a specific response, we would like to have a specific data model with a vendor, with an iOS version, and the uptime in hours for the key value basically, or for the specific, so we would like to output the text or this data from the data points from this text. So these are basically the 3 data points we would like to have. Now, let's see how we can do it. So I will go here into my browser. So this is basically a Python script. I won't go strictly into the code, but like I just would like to show you this one here. I will go further on. So this is the data model. So I'm basically saying I would like to have the output of a show command, here the show version command, with only where basically the LLM is mapping the iOS version to the specific text, and also the configuration register. So if I execute this now, and I am, by the way, connected to the sandbox there, you can see like I have here this show version command. And within this show version command, like there are some parameters. Like there is here this configuration register. There's also like at the top, you see, for example, like here this version. And I model actually like in a variable, like if I execute this one here, I model this one into the variables. So like, okay, what does it give us, right? So like if you need, like if an agent and agent communication, if they work together, you can basically say, I would like to have agent 2 only gives us this specific output or the config register as an output, or any other variables, what you think is good for you. So I hope you can connect the dots here, because in the end, it's about when the agents are communicating, when the agents are basically communicating to each other here, like the output needs to be defined as well, right? And you can basically say, I would like from this interface only this specific term. Or I would like from this whole agentic workflow, I would like only this specific variable. And this is, I think, very important or very cool, like in order to have like this whole output together. All right, so like with that being said, it's about agent frameworks. So like what kind of frameworks are out there? So again, this is just like a selected list, not like a big one. But they are like, I also put some GitHub stars there, but they I would say it's definitely not exhausted, but they are like frameworks which are like where good companies are behind them, and where they are like, which seems at least really promising in order to do something there. It really depends on specific like parameters as you have, like how, like when do we want to push this in production, what kind of telemetry service or debugging you're using, and so on. So this is like the whole thing what you need to test, of course. So like I tested all of these frameworks there, and everything is different. From documentation, from like specific arguments, from specific like LLM support, function control, for tool calling, a structured output. So like this is all like very, very, very different in a way. Now, when we just go back to this slide here and see agentic workflow, like how does it work, like with specific agent? The whole like frameworks, they assemble basically, like not all of them, but they assemble code. So with that, like with function calling even included, they are assembling code for you, like which are executed. So you define the task, and they define the task in the code. An example. This is like the code actions from these agents there. So like we had this example before with about the thought and the action and so on. Like how does it work in the backend, behind? Like what does the LLM or the AI agentic framework do? They just basically create Python code, their own function. Like this is, for example, functions which is created by the LLM, so not by you. So the LLM is creating code in order to get this going, in order to solve your task. Some functions, like the port config check, for example, you define. But for example, like file save, like save the markdown file or the text file as an output, the LLM can easily write. The LM can easily say, all right, this is the task, output the specific code or the specific content in Markdown, and then it just execute the Python command file save. Okay, so then let's move forward, and then one slide before the use cases where I can show something. And this is about AI agents, like use cases and how to think about to create them. You need to think in a different way. You need to think goal-oriented. So not like workflow-oriented. You basically need to say, especially for creating use cases, like make an error or find an error, and then see or create a workflow for this, not specific error, but for this group of errors. And then see and how, if an agent, like an LLM with coding, can do it. And this is like a complete other approach what we are doing right now we are writing like scripting and automation scripts and like the whole thing, like which is very process-oriented and very task-oriented. But like AI agents part is like, you need to give them, like not of leeway, of course, like, but you need to give them smaller, errored task basically, in order to see, okay, how can they solve it? So, with that being said, moving more into the use cases with a code example there. One example, what I was talking with a colleague of mine to see, all right, what would be like a really cool example to check. So, this would be one. Configuration post check with NTP. Like NTP as an example, but there could be many post checks with the configuration. So think about this right now. We are connected now, my laptop is connected to the Catalyst switch. I configured the NTP server, and this is the only diff, the only configuration diff where basically I've changed. Like this is basically a configuration change. Then something gets triggered. Like it can be a GitLab pipeline, it can be anything, an API call. It triggers an AI agent to say, give me the diff, give me this specific command, and now create basically checks, or the output should be a test report. And what kind of like functions, external functions, do we give the agent? We say, get credentials from our database, ping the device, like basically saying the AI agent itself can ping the NTP server, or we can also do and say an API call that the ping basically from the Catalyst switch the NTP server. And also, and yeah, of course, be careful with that, and also definitely create some filtering there. The AI agent is able to do show commands on the Catalyst switch. However, with the restriction of the string of the command can only start with show or sh. And this is very important because you don't want any LLM to configure or do something in your switch or with your switch there. So basically, like, be definitely aware of it, just to take the data basically out of it. All right, so now let's go into the specific code there. So I have it here, and you can find this on GitHub as well. I also included, and I will show this in a bit, telemetry, so like open telemetry, in order to see the steps inside of the agent. And I will just skip through it, like here's the tool call parameter, here's all the parameters, how to get the data and so on, and here's the workflow to see actually, this is the host of the IP address and the configuration diff. Anyways, I will just execute it. And because of so I'm using small agents there. So this is basically the prompt input, and says, here you see the configuration line, ntp server pool.ntp.org. And you can see here what it does. So basically it says here, this is the prompt there, follow specific rules. It actually calls the function, which is predefined, get username and password for the device. It gets the function. This is the execution log. Like this is the output of the specific functions, which is getting back to the AI agent, to the LLM. Then it runs a show command. And here in this show command in step 2, you can see it actually does the show command, show NTP status, on this host, on this username, developer, Cisco IIS, device type, and you can see, clock is unsynchronized. Okay, there might be something wrong. Let's see. Let's go to step 3. So now, actually, it does run a show command there. And you can see an LLM, and this is also what I would like to show with a live demo, is you always get a different output when you use an LLM. So you need to be careful with that. Error handling is very important here. Here, for example, I use the show command ping pool ntp.org, which is basically wrong or not allowed in this way. So here I basically said to the LLM back error, you're only allowed to run show commands. Try again and use a show command. Let's see if it actually did or not. In this way, no, it didn't, but it sent a ping from the agent. So basically it says, all right, there is something wrong, like pool NTP org can't be reached. Then here again, it says something, okay, show NTP associations. And here is the configuration test report there. Let's see if we like it or not. Basically, it says here, summary of the test, NTP status, the clock is unsynchronized. Ping to the NTP server failed, it's not reachable there. No NTP associations are found, and this is not synchronized due to the inability to reach pool NTP org. So in this kind of way, let's check also the recommendation there. Ensure the device has internet connection and check firewall settings and so on. So like, here you can see like a sample output what it does. So like, why is it not working like with that? Because this is we are running like in the sandbox there. Like this is, I configured it, I reserved this iOS XD Catalyst 8KV sandbox there, and this is where like it's highly restricted with security, so that's why it can't get out of it. So like with that kind of point of view, I would say it basically says, yeah, let's show, actually the second point is good, check the firewall settings, so I would say this is in a way correct. All right, so another use case, for example, what can be possible is about this one. So I would say like a classic tool, like analyzing syslog messages. So here we have again a catalyst switch. Some syslog event happens, maybe you say severity below 6 or below 4, whatever you like. And then again it triggers something. For example, like I have it working with Splunk, where something gets triggered, like with a webhook, and then it goes to the agent. And the agent is basically analyzing the specific SSH or the error message, and even does a web search. It even does for you, basically says, all right, this is the error message, give me all the results back about this error message, and then please summarize it and give me a solution summary there. All right, so let's see what it does. We have it here in the specific code there, so let's clear this up. Python, and it is called analyze syslog. So what I did as well, what I included in the function is, I said I'm trying to log in with SSH. This is a deterministic function, and it fails. Like in order to create some logs, I put this in the prompt here. So like this is the prompt, and it's saying like, okay, this is basically extract the error from the provided logs, like I'm giving it already, because this is also fine to have an input from a deterministic function into an agent. It's also totally fine. You don't need to always call and do the tool calling inside of the agent. You're all like inside of the LLM or inside of the reasoning loop, basically. All right, so what it does, it's like this. This is the error message, and it basically says, all right, it gives the task itself, like the specific agent which is dealing with the whole coding, is giving it to another agent, which is basically the helpful agent named search. And this search agent is all about getting data from the internet about this specific error. So here we see, all right, it goes to Cisco community, it goes here to SSN authentication issue, it goes here to the web search there, and so on. And then basically, it continues with specific information there about this. We can also check this out. And then it basically says here, like this would be the final answer. We also reached the maximum steps there. But here is basically like the outcome there. So authentication error user, it's not typically indicates an issue with the username. So this would be right, because I basically said, okay, we have here an authentication error there. And here, these are some issues. This is the empty username. You can use this in order to configure the user, or for example, the AAA configuration missing credentials there, or SSH configuration verification. So like there are some like the classic tools for what you see here. In the end, yeah, this is just a summary in order, like the summary out there and the final answer. Now, I also said we did also some telemetry. Like we had some telemetry also included in the code. So here, I'm going to Phoenix now. So Phoenix is like a classic, I'm making it bigger, is like a UI where you put in, and we see here the two agents which we're running just right now. You can see here a good debugging tool in order to see what is actually possible in order to debug, in order to understand the specific agent they run. So let's go, for example, like here, this one to the code run agents there. So you see, if we go here to the agent to the step 1 here, that the agents, let's go to the LLM output here. So I'm closing the system prompt. This is the system prompt. You see here the user input. So the user input with examples for testing, like what we basically told the LLM, the whole input there. And you see what the agent is thinking, like the output of the agent in the first step of the how was it called, like of the tool call of the first use case, there. I need to test the configuration changes that were made to the Cisco device. All right, here it goes. Check the NTP status, ping the NTP server, check for NTP synchronization, and so on. So like it basically says this is the tool what you use, and it also creates the code. It also creates the code around it. And here, if we go even further, we can also see like the output of the function. Like the output of the function was return a username and password. Developer, Cisco, and this is the password. Let's continue to step 2, for example. Again, like I'm closing here the system prompt and also like the first step message, and this is the first step call. So here is basically from the second step, this is the output. All right, I have successfully obtained the user, developer, and password. And now I will basically, proceed with the following steps. Check the NTP configuration, and so on. So based on the whole thing, as you can see, like it's a loop. It's a loop where the agent is talking or thinking to itself, adding code to it, like adding code as in here, for example, like the show command there, in order to execute. And we can continue this, like, you know, the whole down the steps there, what kind of like simple tool callings there were, or like how basically also the last step was the summary of the whole test there, which is the output there. So this is what's really helpful, of course, and for you, I hope for the understanding as well, is very important how basically like the whole agent is thinking. Yeah, like here, lots of text, of course, like in order to need to understand it, but I think this is basically the most important part to what does the agent think there. All right, so coming back to a couple of the last slides still. So I told you before, so like Outshift or Cisco is as well, we are a lot engaged in the agentic world, especially in Internet of Agent, basically, as we call it. So we are working basically on an open, interoperable, agent-first like infrastructure. So basically like a framework, like not specifically, but like frameworks can talk to each other, like a specific like standard-like as you wish. So how we see it is that basically at first was the internet, classic bare metal virtual machines, then software as a service, cloud native, microservices. But then in the future there, like the next step is assistants talking to each other, agents talking to each other. We can use with the structured output, we can use classic English, like our normal language there, our like natural language here, in order to talk to each other. But of course, it's all about research, how they behave together. The outlook, the vision, which is basically will sooner come, or what is basically like there, is about having in each kind of like scenario, industry, in each kind of like infrastructure, services, however you would like it, basically like interfaces of specific AI agents there and how they are talking to each other, creating specific workflows. We talked about like a workflow example, we talked about the collaborative agentic example there. So like think about this like way in the future, how this could be done there. All right, so like to sum it up. So we talked about AI recap, machine learning, training versus inferencing, predictive and generative AI. I hope this was really useful for you. AI agent, so it's all about a loop, orchestration loop. You can use any kind of like LLM there. Then specific tools there, function calling, tool calling, very important, especially to get deterministic function inside the orchestration loop. And of course, like to have memories doesn't hurt as well. Multi-agent architecture, so like there are some approaches there. I also showed you some frameworks, which again, like figure it out. Like it depends on the use case, what you like. Or are you like more of a Python guy? Are you like more of a Go guy? Are you like more of a like? Do you like the documentation? How much time do you have? Do you want to move to production? All of these questions are important to check the framework there. And finally, like our take, Cisco's take on the framework, like Internet of Agents, agentic workflows, like on-prem infrastructure is, I think, very important for that because, like I said before, AI agents, they're using inferencing. AI agent, of course, can be used for some training data, but in the end, AI agents, they are using inferencing in order to call the LLM and get some output there. With that being said, thank you so much for being here. I hope this was really useful to you. If you have any questions, of course, feel free to reach out to me at the session, after the session, via WebEx, whatever you like. And yeah, if you have any questions, WebEx Teams room is open. And of course, please fill out your surveys. Thank you so much and have a lovely Cisco Live. Thank you so much.